So when we met on Friday, what we were asked to do is the addition or subtraction of these. So the first thing you're going to do is you're going to start by doing the addition of your seconds. So you're going to add the 52 and the 28. When you add 52 and 28, you get what? What is it, 70? 80? Now, that number for our minutes and seconds does have to be less than 60. So I'm going to pull off a 60 off of there. When I pull a 60 off of there, what's left over? 20. So this becomes 1 minute and 20 seconds. So I have to remember to add that 1 minute when I'm doing the addition of those minutes. So that's the next thing I'm going to do, is I'm going to do the 55 plus the 22, but don't forget I had that one that needs to come with it. Yes?
For the next question, when you do 4 times 36, you get 144. So you transfer 1 over to the 9's place for the next place. So do you do it 4 times 10 or 4 times 9 plus 1?
So when we get to the second one and we do the 4 times 36, and you told me it was what, 140?
144.
So you're going to pull off 2 of the 60s. And 2 will be added to the next unit. Does that make sense? So, because I have, if it's 140 something, I'm going to pull off 120, which is 2 of the 60s.
Okay, yes.
Okay. So when we do this addition, we're just going to continue as a refresher with this. When we do this addition, we have 55 plus 22 plus 1 more, and you get 78. Pull off a 60. When I pull off a 60, what do I have left over? 18? Okay, don't forget that when we do our very last addition, which is the degrees, to go ahead and add that 1. So I have 7 and 8 and then 1 more. So I have 16. And so what we had with the answer was 16 degrees, 18 minutes and 20 seconds. Okay? That's our final answer from Friday. You all remember from Friday? Okay. So go ahead and do these next 2, and I'll come around and give anyone help that needs it. So on B, what you need to do is you need to multiply the 4 times the 9, the 4 times the 36, and the 4 times 12. So what is 4 times 12? And then 4 times 36 was 140 something. What was 100? And then 4 times 9. Now we ask ourselves, is 48 less than 60? So we're good to go. Is 144 less than 60? Well, good morning to you all too. The 144 is obviously bigger than 60. In fact, we're going to pull off 60 twice. So when you pull off 60 twice, what does that become? So that is 2 degrees, because we pulled it off twice, and 14 minutes, is that right? 24? 37, who knows? We're just going to make stuff up today. So I need to add that 2 degrees onto the 36, and so my final answer is going to be 38 degrees, 24 minutes, and 48 seconds. How was that? Okay. So far what we've been doing is we have been carrying, we've been go ahead and whenever we have bigger than 60, we carry that on to the next one. Now, just like when we do subtraction, if that number that I'm subtracting from is too small, I need to borrow. So we take the 54 minus the 6. Well, I can't do 54 minus 6, so I have to borrow. So I'm going to borrow a degree from here, and that makes that 75 degrees, 66 minutes. And that allows me to do that subtraction. So then I'm going to subtract off 18 degrees and 54 minutes, and what do you all get as an answer? Yeah, I agree with you. I'm on them too. 57:12? Do you all agree? Anyone have a question on that? Anyone have a different answer than that? Because I have some people that's like, I have no idea what the hell she's doing right now. All right. So when you all are in calculus next quarter, everything's in radians. So we need to describe what a radian is in terms of your degree. You've got to be fluent to be able to say, I know 135 degrees is 3 pi over 4 radians. Everything's going to be in radians for the most part. So you're going to see a lot of the homework, you're going to see a lot of the test questions, and it'll say convert into radians or give me the solution from 0 to 2 pi radians. So when we're talking about the degree into radians, we know that as we rotate around the unit circle just means that it's a circle where center is at the origin and its radius is 1. So a lot of what we're going to be doing is we're going to be spending a lot of time in the unit circle where its radius is 1. So what we know is that if we go around the circumference of any circle, this is going to be 2 pi r. Well, for us, because the radius happens to be 1, this is going to be 2 pi. We know from earlier that 360 degrees is 1 full rotation. So 360 degrees is 1 full rotation. That means we are at 2 pi. So the conversion that we use is we say 180 degrees by dividing both sides by 2 is pi radians, RAD. We should always, when we're talking about radians, put in the word RAD, just like when we're talking about degrees, we do put the degree symbol in there. But what happens is we get a little lazy. We do get a little lazy. So later on, we're going to see, what is the sine of pi over 4? Well, the assumption is that it's in radians. But pi itself is not radians. Pi does not equal 180 degrees. Pi is 3.14 ish. So be careful that when we first start to learn radians, we are in radians. It should always say RAD afterwards, but we do get a little lazy. I'm going to tell you straight up, I'm going to put this on the test. I'm going to ask you, is 180 degrees equal to pi? No, it equals pi radians. 180 degrees does not equal pi. Pi is 3.14 ish. 180 degrees is pi radians. And I'm going to put that on the test, true or false. And I'm praying this is the class that says false every single time. We'll see what happens. So here's our conversions. We convert from 180 degrees is pi radians. 360 degrees is 2 pi radians. The most convenient one is usually this one. It's the one we almost usually use. Because the other one means that I have to do some more divisions by 2, and who wants to do extra steps if we can avoid them? So that's the conversion that we use. Is there any questions so far? Okay, cool.
Did you say rads?
Yes, RAD, radians. Yeah. So if I'm asked to convert any degrees into radians, then if I were asked to do the 135 degrees, I would multiply by pi divided by 100 degree. So the pi there is in radians. So it's pi radians over 180 degrees. And I do my cancellations, and I'm trying to find the largest number that goes into both 135 and 180. And my answer is 3 pi over 4 radians. Okay? Yes?
How do you know it's in radians, like from that? Like you know 135 degrees times pi over 180.
So the question he had was, how do I know it's in radians? Is because when we're doing a conversion, we would put RAD next to the pi. And so when I see this, pi over 180, that means I'm doing a conversion from degrees into radians. So radians should have been there. I was a little lazy already, and I dropped it off. My answer is 3 pi over 4 radians. And because we are almost always in radians, what we're going to see later, especially in the book, the textbook, and homework and stuff, when you see 3 pi over 4, it's assumed in radians, because we're now into degrees to radians. So if you all can convert from degrees into radians on this next example. All right, so what we're doing is we are doing the conversions from 30 degrees. So I'm going to multiply by pi over 180, and it is pi radians. And I'm going to do a cancellation. 3 goes into 30 once, 3 goes into 186 times. So I have pi over 6 radians. How was that? Okay. I'm going to do the next one. I have pi 180. What did you all get for that?
5 pi over 4 radians.
So 5 pi over 4 radians. Did anyone get a different answer than that one? All right. Do the next one. We have pi over 180. Don't forget to have the negative. And when this reduces, what do you all get when you reduce? What'd you get? Over 15. What was it? 2? So negative 4 pi over 15 radians. You all agree? Is there anyone get something different? All right. So now when we are converting back, we just take our unit fraction and just do the reciprocal of the unit fraction. So if I'm asked to do a negative 300, no, I want to do radians. So let me do radians. If I do a negative 5 pi over 3, and I want to turn that into degrees, then I'm just going to do the reciprocal of my unit fraction I just had. So this time my pi is going to go in the denominator, and in my numerator, I'm going to have 180 degrees. Here, my pi's cancel, and I'm still going to continue the cancellation. So 3 goes into 3 once, 3 goes into 180 60 times. So then I just do the negative 5 times 60, which is a negative 300 degrees. All right? So when we are doing conversions backwards, we're still using the pi radians to 180 degrees, just this time we put pi in the denominator and 180 degrees in the numerator. So go ahead and get those answers. Raise your hand if you can give me the answer to the first one. Yes? 90 degrees. Does anyone need to go over that? Would anyone like to go over that? Okay. Raise your hand if you can give me the answer to B. Yes? Do you guys agree? Disagree? Let's go over this one then. So what I'm going to do is I am going to multiply by the unity fraction. This time I'm going to make sure my radians are in the denominator. So I'm going to put pi in the denominator, 180 in the numerator. I'm going to cancel my pi's right out of the gate. And then I'm going to look to see if I can do any cancellations between 12 and 180. So is there any cancellations between 12 and 180? What does it cancel down to?
15.
So 12 will go into 180 15 times?
Yeah.
Bless you. So then all I have is I have the 15 times the 17 degrees, which is what? So 255 degrees. Is that what you said? Oh, okay. Okay. I was like, because I remember some, I could have just misinterpreted. It could have been me. It could have been me. Easy fix then. Any other questions on that one? Okay, so last one. Raise your hand if you can give me the answer to the last one. Somebody I haven't heard from yet today. Yes?
Negative 1260 degrees.
Does anyone have a question on that one? In this case, the only thing that when you did the unity fraction that canceled was pi, so then you did 360 times 7, and don't forget the negative symbol on there. Any questions? Okay, cool. So a lot of what we're going to be doing is spending time with reference angles. Reference angles will be your friend. It will be the friend that you sneak out of the house with at night. It is that close of a friend. You're going to become one with it. You're just going to love reference angles. What a reference angle is, it is the shortest distance from your terminal side to the x-axis. It is always to the x-axis. And it doesn't matter which way you rotate to get to the x-axis. It is the shortest rotation from the terminal side to the x-axis. So in this case, my reference angle is the same angle because I'm in quadrant 1 and I've not done a full rotation. In this case, the next one is my reference angle is going to be as I go down from the terminal side to the x-axis, and as always the x-axis. Notice in this case I'm actually rotating in a different direction to come back to the x-axis. It is always the x-axis. Let me say that one more time. It is the distance to the x-axis. It's a rotational distance to the x-axis. Is distance ever negative in this class? No. Our reference angles are always positive because it is a distance rotation to the x-axis. All right? So this one, so in quadrant 3, I am coming back to the x-axis. In quadrant 4, I'm moving toward the x-axis. Okay? It is a distance rotation to the x-axis. We note the reference angle as theta prime. That's just a notation to talk about the reference angle. So when we start talking about what sine and cosine is if I want to find the sine of 135 degrees, all I have to do is find the reference angle to 135 degrees. The way I do that is I realize I'm in quadrant number 2. So I'm going to take 180, I'm going to subtract off 135, because that's 180 is my closest reference angle, or my closest x-axis. And so my reference angle is 45 degrees. So the sine of 135 is the same thing as the sine of 45 degrees when I go to do the evaluation of it. All right? So yes?
So you can't go backwards like on that third one, on the third one?
So if I wanted to know the sine of 225 degrees, I'd be in quadrant number 3. So in this case, to find my reference angle, I would do 225 degrees, and then I would go backwards to my closest x-axis, which is 180 degrees. Yes?
It was suggested to me to wherever the angle is, if you can drop down a perpendicular line, will be where you, what were we just
Reference angle.
reference?
The reference angle is always on the x-axis. Always on the x-axis.
That's what I was saying.
Yes, but if you say perpendicular,
Oh, well.
perpendicular can go left, or it can go left and right or up and down. So let's go x-axis.
Exactly.
Okay? So this is 45 degrees. But what we're going to learn, this becomes a negative, and then we'll learn this, don't worry about it now, the negative sine of 45 degrees, which we will learn later as to why it's a negative sign. So the step that I skipped in there, which we will get to, this is the same thing as the sine of negative 45 degrees, because sine is negative in that quadrant, which we'll learn not right now. Okay? So reference angles is the shortest rotational distance from the terminal side to the x-axis. Notice when I'm in quadrant 3, it is my terminal side angle is my angle minus my x-axis. When I'm in quadrant 2, it is my 180 minus my angle, because these are always going to be positive. Does it matter if I did it the other way? No, not so long as I remember it is going to be the absolute value of it, because it is a distance. Is there any questions? Cool. So go ahead and find the reference angles in degrees and in radians for these lovelies A, B, and C. If I'm asked for a reference angle, the first thing I'm going to do until I know where everything is I'm going to draw an XY chart or an XY plane. On my XY plane, I know that this is 0 degrees. I know this is 90 degrees. This is 180 degrees. This is 270 degrees. And then I'm back to 360 degrees. That's just so I know where I am, so I know where my closest x-axis is. Also on here, I'm going to do my radians. 90 degrees is pi over 2. 180 degrees is pi. 270 is 3 pi over 2. And then, of course, we get back to 2 pi. The only reason I'm doing this is so I know which quadrant I land in, so I know if I'm subtracting 360 minus that angle, or if I'm taking that angle and I am subtracting 180, or if I'm taking 180 and subtracting that angle. I just need to know where my closest x-axis is. So my first one, I'm asked to find 330. I'm down in quadrant 4. So I know that the reference angle for this one, because I'm in quadrant 4, my closest x-axis is 360. So I'm going to do 360 minus 330, which gives me 30 degrees as my reference angle. That is my reference angle in degrees. When I convert that into radians, these are my reference angles, so I'm going to note them as theta prime. In radians, this is pi over 6. Was there any questions on that one? Yes?
So you don't write, on video paper, you're writing sine equals sine to the 30, you don't write that?
Not yet. Not yet. All we're doing is doing the reference angle. All we're doing is doing that conversion. We will get to saying the sine of 330 degrees is equal to the negative sine of pi over 6. We'll get there. We're just not there yet. Okay? Now, on this one, I take a look at this, and I'm just going to look at the fractional part and ignore the radians. So if I just look at the fractional part, this is 7 over 6. I'm trying to decide, if I come back over here to my xy plane, this is 1.5 times pi. I know that this is just 1 times pi, and this is 0.5 times pi. So I'm trying to figure out where 7 over 6 lies. Is 7 over 6 bigger than 1? Is it bigger than 1.5? No, it is bigger than 1, but less than 1.5. So when I do that one, what I'm going to do is I'm going to do 7 pi over 6 minus pi, because pi is my closest x-axis. I'm down in quadrant number 3. So in other words, I'm going to do the fractional part and just slap pi on the answer. So I have 7/6, which is 1 1/6, minus 1, which is pi over 6. And again, we are finding theta prime, a reference angle. And in terms of degrees, we know from the previous one that is 30 degrees. Does that make sense? Okay. The last one is negative 3 pi over 4. So now I'm going to go in the clockwise direction. And with the clockwise direction, I'm going to be going in this direction. And I ask myself, is 3 over 4 bigger than 1? Okay? It's not bigger than 1, and if I'm going in the negative, this would be negative 0.5. So which quadrant does that land in? It lands in quadrant number 3. So I take pi, I subtract off 3 pi over 4, and I get pi over 4, which is the same thing as 45 degrees. How is that? So when you're in radians, you're chasing decimals, or you're chasing the entire time, you're chasing fractions, which is unfortunately that's where we're going to be for most of this class, and definitely in calculus, is in radians. How are we doing? Yes?
So for the radian on A, if you go to 11 pi over 6, is that wrong?
So all of my reference angles in terms of radians should always be less than pi over 2. And what did you have?
11 pi over 6.
No, is that, so 11 over 6, is that less than or more than 1/2?
That's more than
So that's why, yes, it is incorrect, because all reference angles are less than 90 degrees, because we're doing a rotation to the x-axis. So we're always doing a rotational down. So what you probably found is the degree, or is the radian measure. You just have to figure out what the reference angle is to 11 pi over 6.
So how you got pi over 6 was you just did the conversion where you did degrees over
Are you asking about A or B?
A.
Okay, so on A, yes. So when I got 30 degrees, I just converted that into radians, which is pi over 6. And by the way, within about 2 or 3 weeks, you'll all know that conversion's on the top of your head, because we're going to be doing those so frequently. The 30, 60, 90s, and the 45s in each quadrant, you will know those very, very short order.
Oh, and so when the reference angle, you subtract the position on the x-axis, you subtract your original angle from that? Or it doesn't matter because it's...
Actually, it doesn't really matter if you don't want to remember which one you are, whether it's a 360 minus the angle, or if it's just the angle minus 360. It doesn't matter as long as you put absolute values, because it is a distance thing.
But then when you did that before on the previous example, you had a negative sign, 45 degrees, so we don't have to...
No, these are always going to be, the reference angles are always going to be positive. Reference angles are always positive.
But on that previous...
Right, we're going to get there. Don't worry about that. It was just, this is a preview of where we're going. That is not what we're doing right now. Yep. Okay. So the next thing that we have is the arc length. There's a lot in this section. There's actually quite a lot in this section. The next thing we're going to be looking at is the arc length. So the arc length is given by S, as how we denote it, and alpha is the angle in radians. So when you all are doing the homework and you get the wrong answer, you need to ask yourself, did I put in radians or did I put in degrees into that formula? It is always in radians. So alpha is the angle, and it is always in radians. Alpha is always the angle and is always in radians. And then to find the arc length, you just multiply that by whatever your radius is. And that's it. That's your arc length. So as we take a look at this, and they're asking me for the arc length given by the angle and the radius that's given to us. I'm going to call that 1 radian. 1 radian is a very, very small rotation. So it's already in radians. Now, the question I ask you is, why doesn't that have pi attached to it? Does it need to have pi attached to it? No. Does not need to have pi attached to it. It's just 1 radian. So I'm going to take that 1 radian. That's my S. Looks kind of like a weirdness. And that's only because my S's and 5's look the same. So my S is always cursive. My S's are always cursive because otherwise it looks like my number 5. I'm just going to multiply that 1 times 4, and my arc length is 4 centimeters. Yes?
What are you going to ask for the angle?
Sure. So the question was, what happens if they ask for the angle? Well, then I'd have to know what the arc length is. Let's assume the arc length is 12 centimeters and my radius is 3. Then I just go ahead and use the same formula. I have 12 is equal to alpha times 3. Alpha is 12 divided by 3. Alpha happens to be 4 radians. Okay? So go ahead and do B. Find an arc length. And what has to happen before you can throw it into that formula? You have to convert that to radians. That is the first thing you must do. So the first thing you're going to do is convert your 60 degrees into radians. So I do 60 pi over 180, and I get pi over 3 radians. Do you all agree to that? Okay? So then my arc length is going to be equal to pi over 3, which is my alpha, times my radius, which is 2. So 2 pi over 3 meters. And I can leave it like that, or I can put in my calculator 2 times my pi symbol, 3.14 divided by 3. So somebody who did the conversion, give that to me to 3 decimal places. 2 times pi divided by 3 to 2 decimal places. Or excuse me, 3 decimal places.
2.09.
So this one here, the 2 pi over 3 meters is the exact answer. So if you see anything on the homework that says give the exact answer, that is the exact answer. The 2.094 is an approximate answer. It is not an exact. So there's going to be times where it's going to ask for exact, and there's going to be times for approximate. So pay attention to what they're asking, because if it's marked incorrectly, you probably did everything correctly, but you're not giving the answer in the form that they want. When I see you all tomorrow, we're going to go in through to the area of a sector of the circle. We're going to do some angular and linear velocity, and then we'll have finally put 10.1 to bed. I would highly recommend that you start the homework on this already, because the homework should follow what we've done so far. So please don't wait to start 10.1. There's a lot in 10.1, and I want you to understand it. So please consider doing the homework starting right after class, even though we haven't finished 10.1, and go as far as you can. Have a great day.